Okay, today we're going to talk a little bit about displacement and density. And these may be topics that you have talked about in your science classes, but we're just going to do a kind of a quick review on those. So what is the displacement? Well, the definition says the displacement is the volume of fluid that rises above the original fluid line when a solid object is placed into the fluid. So if you think about having a container of water, and when you drop an object into that container, you know that the water level is going to rise. And that change in water is, if you find the volume of that, that is the displacement. So here they're kind of showing you a tube full of water where they drop a key in there. And this little slice here, the change in the water is the displacement. If you find the volume of that, that's the displacement. Why would we care about that? Well, that volume of that slice of water, the change in that water, is equal to the volume of the key. And so we use displacement to find the volume of irregularly shaped objects. We don't have a formula to find the volume of something like this. So I'm going to have to use a different method, and that method is to use the displacement. So when I find the volume of that water, it is equal to the volume of the key. Also, another reminder, when we talk about density, well, density here, we're going to define it as the ratio of the mass of an object compared to its volume. Okay, so density is mass divided by volume. Now that doesn't always tell us what density is. When you're thinking about density, you think about, well, that kind of determines whether an object sinks or whether it floats. It really is kind of thinking about how the degree of the compactness of our object, how compact something is. And we're going to take a look at an example that refers to density. First of all, let's take a look at example A. It says that Mary Jo wants to find the volume of an irregularly shaped rock. She puts some water into a rectangular prism with a base that measures 10 centimeters by 15 centimeters. When the rock is put into the container, Mary Jo notices that the water level rises 2 centimeters. What is the volume of the rock? So my container here, 10 by 15, do we know how much water is filled? No, we don't know the height of the water. What we do know, though, is once the rock is dropped in, that the water level rises, and that rise in water is 2 centimeters. That's all we really need to know. So when I think about the displacement, well, displacement is the volume of that change in water. Well, my volume, capital B times H, my area of my base is a rectangle, 10 by 15. And the height, well, the height is the change in water, which would be 2. And so when we multiply those together, we find out that we get 300 cubic centimeters, What does that mean? Well, that is the volume of this water, but it's also going to mean that is the volume of our rock. Our rock is going to have a volume of 300 cubic centimeters. Okay, let's look at one more example. Example B. A clump of metal weighing 351.4 grams is dropped into a cylindrical container, causing the water level to rise 1.1 centimeter. The radius at the base of the container is 3 centimeters. What is the density of the metal? And using the table provided, determine what type of metal is present. Now, if you wanted to, you could sketch a picture for this. If you have your cylindrical container here, And we're going to drop our rock or a clump of metal in there, and we have our water line. Now, it tells me that this is a cylindrical container, causes the water level to rise 1.1. So when we think about how much that rose from here to here, it's going to be 1.1 centimeters. My radius of my base is 3 centimeters. Initially, we want to know the density of the metal. Well, we know that our density is mass divided by volume. Well, I do happen to know the mass. It tells me it was 351.4 grams, but I don't know my volume, and so that's actually what we're going to have to calculate. We're going to do that by using the displacement. So our displacement the volume of that change in water, well, if we have our area of our base times our height, this time our base is a circle, so we're going to use pi r squared. What would the height be? Well, the height would be the change in water. When I drop that clump of metal in, it raises 1.1 centimeters. So we're going to multiply those together. And we'd actually find that our volume is about 31.1 cubic centimeters. So as we go down below, if this is the volume of that change in water, it's also the volume of that clump of metal. We can take our 31.1 cubic centimeters, and now we can simply divide. Now you'll notice when we divide, I do not have the same units here, so I'm going to actually have grams per cubic centimeter. And if you divide those out, you're going to find that you get about 11.3 grams per cubic centimeter. We're going to go ahead and look then up in our chart, and we would find that about 11.3 that our metal must be lead. It did ask for the density of the metal, so the density of the metal would be about 11.3 grams per cubic centimeter. Okay, if you have further questions on this, please stop in and see me.